Hi, 8th graders. Today we're going to talk about graphing quadratic equations. And we know that we have a quadratic equation because we have an x squared here. So a linear equation is y equals mx plus b with an x to the first power. Quadratic equation always has an x squared in it. So we're going to talk about how to graph a quadratic, and it's the same as graphing a linear equation. We just identify some x values and figure out what our y value would be. So y equals x squared, if we fill in negative 3 for x, that would be negative 3 squared, which is negative 3 times negative 3, which is 9. Negative 2 squared would be negative 2 times negative 2, which is 4. Negative 1 times negative 1 is 1. 0 times 0 is 0. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. So when we graph, we would be negative 3, 9. Negative 2, 4. Negative 1, 1. 0, 0. 1, 1. 2, 4. 3, 9. A quadratic equation is always going to be a curve, and this curve is called a parabola. The next thing you need to know about your quadratic equation or parabola is that every parabola has a vertex, so it's either the minimum or the maximum point. In this case, it would be the minimum, the very smallest number, and the vertex would be 0. And then every parabola has an axis of symmetry. And the axis of symmetry in this case would be x equals 0, and it's where each side of the parabola is symmetrical around the axis of symmetry. When we have y equals negative x squared, that means we have negative 3 squared. So negative 3 squared would be 9, and the negative just stays. So our answer would be negative 9, negative 4, negative 1, 0. Here we have negative 1 squared, so 1 squared would be 1, and the negative makes it a negative 1, negative 4, and negative 9. So when we have a negative x squared term, negative 3, negative 9, negative 2, negative 4, negative 1, 0, 0. Our parabola opens down. So when we have the negative here, our parabola opens down. If you look back at example A, you have a positive x squared term, the parabola opens up. Alright, so the vocabulary that we need to talk about is, what is a quadratic? It's a nonlinear function in the form y equals ax squared plus bx plus c. A parabola is the U-shaped graph of a quadratic. The vertex is the minimum or maximum point of the parabola and the axis of symmetry is the vertical line that divides the parabola into two symmetric parts. Identifying the characteristics of a quadratic function. So there are a few things that you're always going to tell me about the quadratic when I ask you to compare or to identify the characteristics of a quadratic. One of the things that you need to know is that the domain is all real numbers. So if I have a quadratic and the vertex is here, my domain is going to be all real numbers because domain again is your x values. So this is going to spread wider and wider, and it's going to cover every positive x value and every negative x value if it goes on long enough. The next thing that we would identify is the range. So the range is going to be all real numbers, but it's going to have a stipulation. Because when you're looking at the y-axis, the range, it'll go up forever from this point at the vertex. So the vertex is at the point -1, -2. And so the range takes a look at that y value and says all real numbers when y is greater than or equal to -2. So that's saying all of these numbers are in the range, but nothing below. Alright, the next thing we want to identify is the axis of symmetry. And the axis of symmetry is the x value of the vertex. The axis of symmetry would be x equals -1. So the vertex is really important in identifying your range and your axis of symmetry. So those are the three main things when I ask for characteristics that you would tell me. Next, graphing y equals ax squared. When your a value, so this value, whatever number is in front of your x squared, is greater than 0, you have your parabola opens up into a U shape. And when a is greater than 1, so not a fraction, but when a is greater than 1, it is narrower than y equals x squared. when a is in between 0 and 1, so fraction that's in between 0 and 1, your parabola will be wider than y equals x squared. When you have an a value that's less than 0, your parabola opens down. Okay, so your parabola when a is less than -1 is narrower again. And when a is between -1 and 0, it is wider than y equals x squared. Alright, so we're going to try one. Graph y equals 2x and compare it to the graph of y equals x squared. So to graph it, we're going to choose some x and y values. I would pick -1, 0, 1, 2. 2 times -1 squared is -1 times -1, which is 1. So that would be 2. 2 times 0 squared would be 0. 2 times 1 squared would be 2. 2 times 2 squared, so that would be 4 times 2 is 8. So when I graph this, I get -1, +2, 0, 0, 1, +2, and 2, +8. So my parabola is going to look like this. And the things that we're going to use to compare is we're going to say y equals x squared is narrower. They have the same axis of symmetry because our vertex is at 0 here. And they have the same vertex. And they both open up. So there's 4 main things that I want you to talk about when you're comparing. Alright, so I have 3 examples for you to compare to y equals x squared. The first one is y equals -5x squared. You can type that into your calculator to view the graph. I personally would do y equals x squared into y1, and then I would type in what you're comparing into y2, and take a look at both the graphs. The first one that shows up will always be y equals x squared, and the second one that shows up will be y equals -5x squared. And so once again, the things that you'll notice about your graph are that -5x squared opens down. The next thing is that -5x squared is narrower. They have the same vertex at 0, 0, and they have the same axis of symmetry at 0. If they have the same vertex, they're always going to have the same axis of symmetry. So I would like you to try B and C for homework. And then I've given you some graphs on the back page. You need to make an XY table. Choose some X and Y values. Choose some X values to figure out your Y values. I would do at least -1, 0, and 1 for all of them. better would be doing -2, -0, 1, and 2. It would give you a better picture. But at least do -1, 0, and 1. That will generally find your vertex for you. And then on number 7, the path of a dolphin jumping out of water can be modeled by this equation where x and y are measured in feet. Find the distance and maximum height of the jump. So when you graph this, you can put that into your calculator. And when you graph it, the maximum height of the jump is going to be the vertex. And the distance of the jump would be whatever the distance is from here to here, which looks like -12 to +12, would be 24 feet. And I guess while we're at it, we can do the maximum height together. The maximum height from water level looks like it is -15, and the dolphin's jumping up to 0, so the maximum height would be 15 feet. So go ahead and try 1 through 6, and then B and C on the previous page.